Good morning, everyone. How's it going today? I just wanted to talk to you a little bit about the new models that we had yesterday. So OpenAI and Anthropic released their new coding models yesterday, and they look amazing. So we have GPT 5.3 Codex, which is their new state-of-the-art model for coding. And we have Opus 4.6 by Anthropic. And the idea right here is that I wanted to make a real comparison between the two for real software engineering tasks, kind of like what we did with Kimi, and to actually figure out which one is best and better in different tasks, right? So the first thing that we're going to do is, first of all, we're going to compare the benchmarks, of course. Second, we're going to try their luck at this particular task. So we have a front end that is terrible, and we want to try both models to see how good they are at actually improving this front end. We're also going to be generating a physics simulation of just space-time kind of gravity like this, and we're going to see which model does a better job at it. We're also going to be creating a web-based game with a single prompt, so we're going to have both models build an entire web-based game. And finally, something very fun, we're going to have both models migrate an entire application from one framework to another. Now, this time it's not going to be both two JavaScript frameworks. It's actually going to be from Laravel with PHP to Next.js to see how good it is. So let's actually try both of these models and let's get right into it. All right, I don't want to bore you with a lot of numbers before we actually go into the tasks and the cool tests that we're going to be doing today. Just to mention that the only benchmark that both models published is Terminal Bench 2.0, and in that one, GPT 5.3 seems to have the better score. So GPT 5.3 has 73.3 score against 65.4 for Opus 4.6, which is already an improvement over GPT 5.2 Codex, which was the state-of-the-art right before that. And just for the record, this benchmark is a benchmark that measures how good a model is at coding. Now, after that, let's just compare really quickly other benchmarks that we have right here. They did not release the same benchmark for the SweBench family. On GDPeval, however, which is a benchmark that measures how good a model is at answering questions that were created by experts in their field, such as economics, politics, physics, etc. And in that one, we have the GPT 5.3 Codex has a 70.9 score. Now, this is something to think about because this is actually the exact same score as GPT 5.2. And we have the comparison of Opus 4.6 against GPT 5.2, and apparently Opus seems to beat 5.2. So Opus seems to be the better model on this side right here. And on OS World Family, we also do not have the same benchmark, so we cannot really compare, but both are very good. And last but not least, let's talk really quickly about the context windows and the pricing. Claude Opus 4.6 comes with a monstrous 1 million context window, which is amazing. However, keep in mind that tokens above 200,000 tokens in input are going to be priced with an extra. On the output token side, we have 128,000 output tokens, which is pretty standard. It is already available in the API, which is not the case for GPT 5.3 Codex. Hopefully, it's going to be available soon. And the pricing remains the same as Opus 4.5, which is $5 per million input and $25 per million output. And we can probably suspect that the context window, the max output tokens, and the API token pricing is going to remain the same for GPT 5.3 as GPT 5.2. And there you go. That's something to think about. Let's actually go right into creating the super cool tasks to see how these models actually perform. All right, so as I told you before, what we're going to be doing for the front-end task is we're going to have both models try their luck at redesigning this very ugly page, which is supposed to be a landing page. And the idea is that actually I have already created this repository. If you want to test it yourself, there is the public repository titled Landing Page Frontend Eval, which contains this exact ugly website so that you can try your luck at improving it with your own models. And what I'm going to do is I'm just going to clone that model, that repo in a couple of directory. So now I have this in Codex directory and a Claude directory. So I'm going to go into Codex on this side, and I'm going to go into Claude on this side. And what I'm going to do is on this side, I'm going to open Claude. On this side, I'm going to open Codex. And as you can see, we're running 5.3 Codex right here and Opus 4.6 right here. And what we're going to do is we're going to be using the front-end design skill, and we're just going to ask the model to improve the design of this landing page like this. And we're going to do the same thing on this side. And that's it. So for the record, we are using the front-end design skill on both sides, and we're going to take a look and figure out which one does a better job. All right, there we go. So on the left side, we have Claude, and on the right side, we have Codex. Let's see which one does a better job. All right, so both of them have finished, and before actually taking a look at the designs, I just wanted to take a look at the context window that both of them still have and how many tokens they used. So on this side, we have that this guy, Opus 4.6, used 41,000 tokens to finish this task, which is 4% of its actual context window because it has a gigantic 1 million context window. On the Codex side, we can see that it used 20% of its context, which actually is almost twice as many tokens as Opus. So here, if we consider that we have pretty much the same context window as on GPT-5.2, we have a 400,000 context window, and a 20% of that is 80,000 tokens, which is almost twice as much as Opus. So that's also not great. And let's actually take a look at the designs. So on the Opus side, we have this very cool design right here. You can see, let me just reload this. You can see a nice hero right here, nice section with nice overlay, nice hover effects. We have these different sections. We have the pricing section, which looks good. We have nice scroll animations. Everything looks pretty good. Let's actually take a look at the mobile. And on mobile, it also works great. Also very nice scroll animations. So in my opinion, this is a definitely very good result for Opus. Let's take a look at the same thing, but for Codex. So here's the same page for Codex. We also have some nice animations. We have this site right here. We have these sections, no more animations. That's all right. But in my opinion, this does look much more dull than the Opus version. The links work, but for some reason, the navbar is not sticky. So I cannot continue using it, even though it's an in-page, single-page navigation navbar. So not a great design, in my opinion. Let's take a look at the mobile version. Here we do have, well, kind of did have, oh, it's not a sticky, it's a fixed side navbar, which is probably not great. And yeah, not amazing in my opinion. So in my opinion, we're going to have to give this point to Opus 4.5. So we have 1 point for Opus and 0 points to Codex, sorry, Opus 4.6. All right, so the next task is try to have these two models generate a complete or kind of realistic space-time simulation where you can actually see the space-time and massive bodies on top of it deforming space-time, so you would be able to see the curvature of it. So ideally, both models are going to be able to do it. I don't think it's super complicated. I haven't actually coded it myself, but let's take a look. Just to show you the prompt that I'm going to be sending, it's this one right here. So it says you're building an interactive 3D educational sandbox in the browser that visually evokes general relativity, but uses a simplified and body gravity approximation, etc. And we have the outcome, which we want to have bodies moving in 3D under mutual attraction, a visible space-time curvature, trajectories and trails, and collisions and mergers. And there you go. You can just pause the video right here if you want to read the whole thing. But let's actually take a look at how good they both are. I'm going to paste the same prompt right here, and I'll be back as soon as they are done. Okay, so here we have the result for both models. They already have finished. On the Claude side, we can see that it used 34,000 tokens, and on this side, it also used about 80,000 tokens like we had for the previous task. So it probably uses many more tokens for exploration and decide. However, on this side, this is only counting the session after it generated a plan. So let me actually add that to the plan session, which is this one right here. Okay, so we have 40,000 tokens on the plan session for Claude, plus 34,000, so that's about 70,000 tokens in total for Claude, and about 80,000 or 70,000 for Codex, which actually is pretty much the same. So let's say that both offered similar results on the context used, and let's see its final results. And there we go. Wow, it actually looks pretty good. The space-time curvature does not look so beautiful. So, I mean, why is there curvature for the smaller bodies and not the bigger one in the center? Let's see if we can add another body. Oh, we have no curvature. Oh, okay. All right, there you go. That looks better. I have the grid resolution. We can increase it, the speed. Okay. All right. And the value of G. Oh, crazy. All right, this is actually very fun. I really like these little buttons, little sliders right here to actually change the whole thing. And we can just restart and it goes back into this thing. I'm really pleased about this. I really like the result. Great result by Opus 4.6. Let's actually take a look at Codex. All right, so I'm going to stop the server on this side and going to just open a live server on this other side. And here we go. We have the Codex animation looking also very, very good. And it is actually real 3D with multiple space-times layers right here, which is probably a little bit more realistic. Looking great, beautiful. Okay, let's see if we can increase the gravity strength. And by increasing the gravity strength, of course, the bodies start falling towards the larger body. We can just increase the simulation speed as well. Okay, actually, I am very happy about this one too. I'm not sure if this is better or worse than Opus. I would say that it's a tie, actually. You can decide for yourself which one you prefer, but I think both did an amazing job. So great, good point, good one for both. So I'm going to give 1 point to each. So we have 2 points for Opus and 1 point for Codex. All right, so there we go. For the next task, we're going to have both of them try their luck at creating their own version of the Angry Birds game, and the idea is that they're going to build it completely in the browser. So I'm going to be pasting this particular prompt right here. It's very open and very flexible so that the models can actually make decisions that will lead them to a better result. So we have create a 1-level Angry Birds style browser game with slingshot projectile physics, requirements, drag to aim slingshot mechanic, projectile trajectory arc based on launch force, stack of destructible blocks, score system and level reset, and runs without build tools in browser. And just for the record, I'm going to be enabling plan mode on both to be sure that they actually think about this through and then implement their solution. Okay, so both of them finished. Let's take a look at them. We see that Claude created a single file, so how about we open it? I'm going to npx serve it just to make sure that any CDNs are actually loaded correctly. And there we go. Well, the birdie didn't really follow the trajectory, did it? And it's still moving. Okay, all right, I guess I won. Let's try that again. I don't like that this guy completely falls, and I also don't like that it doesn't really follow the trajectory that it drew. Okay, let's say that this is an okay result. I was actually expecting better. Codex, on the other hand, built 3 different files. Let's also npx serve it. So I'm just going to npx serve. I'm just going to close this one, reload, and this is even worse. Okay, I guess both of them are going to fail. However, the Claude Code one actually looked way was actually at least a little bit playable, and it had the actual little porky pigs right here. So, nope. Wow, this is a point for Opus. I was not expecting this. So current score is actually 3 points to Opus and 1 point for Codex. Crazy. All right, so the next task that we're going to do is super fun. We're going to be migrating a complete application from one framework to another framework. And actually, in a previous video, I used a migration from Angular to Next.js, and that was pretty fun. But I feel like we can actually step up this game a little bit, and we can actually try to migrate from Laravel, which is a PHP framework, all the way to Next.js, which is a JavaScript framework. So hopefully, the models are going to do well in this task. And the application that we're going to be migrating is the one that you see right here. This one, for the record, is running on Laravel. And as you can see right here, it is City Pulse. It is connected to OSM and to Open Weather APIs. You can search, for example, for Paris. We can search for it, and it will display the cities that are similar to what we're looking for. In this case, it is Paris, like this. And it just basically displays the weather, just a very nice simple map right here. And the daylight, the sunrise and sunset times, and the air quality data. It's a very simple application, but I wanted to make it a little bit more complex than the previous one, which was a CRUD application. This one actually interacts with an API, so that we're actually seeing a little bit of more complex migrations. So let's take a look at this. What I'm going to do is I have actually cloned this exact application in a starter directory right here, and I have created an empty Codex and an empty Claude directories, as you can see. So what I'm going to do is I'm going to go to each one of this. All right, so as you can see, I have both agents open, one in the Claude directory and another one in the Codex directory. On this side, I'm using GPT-5.3, and on this side, I'm using Opus 4.6. So let me just paste this prompt right here if you want to take a read at it. And I'm also going to enable plan mode on both to be able to actually test them to the maximum of their capabilities. So let's see what they do. Okay, so both agents finished, and Codex actually took shorter than Opus. Codex finished in like 5 minutes, and Opus finished in like 20 minutes, and it had quite a bit of trouble actually figuring out what it had to do. And also, I had to actually start accepting every single thing that it wanted to do, because I forgot to enable the sandbox. That being said, yeah, the time difference is significant. On the context side, we see that Opus spent 120,000 tokens, which is a lot, but it's only 12% of its gigantic context window. And on the Codex side, we have that it spent 31% of its context, which for a context of 400,000 is about 120,000 tokens as well. Yeah, I mean, both spent pretty much the same number of tokens. That being said, Opus did spend a little bit more because it resets its token count once it finishes the planning stage. So that's quite an important thing to note. That done, let's actually see the results. So I'm going to npm run Claude. Oh, by the way, I have also already added my API keys, and Claude seems to be doing quite all right. It's a very straightforward app. It did change a little bit of the app. As you can see right here, it changed Laravel to Next.js right here, and Laravel to Next.js right here as well. But let's see if the city search is still working. So Paris is working. Use the city. So that's for Paris. Paris seems to be okay. The leaflet map seems to be okay. It is also responsive, I think. Yes, it is responsive. Okay, so things look great. Let's test Codex now. So I'm just going to go right here to Codex, just going to close this right here on the side. Going to npm run dev on Codex. This one right here is the Codex app, and as you can see, it is also pretty much the same. It did not change Laravel to Next.js, which is good, I think. It's a good thing because I did not ask it to change anything. I actually asked it to not change anything. So it left Laravel even though it is built in Next.js. And the font family does not seem to be the same. That's the only problem that I see so far. Let's test the search bar right here. So if I search for Paris, I select Paris, and it shows the whole thing. Everything seems to be okay, the leaflet map. And let's take a look at how responsive it is. And okay, it's looking all right to me. Oh, the map, okay, it kind of had a small issue there, but it's there and it's working correctly. And okay, so this, you might think that this is not responsive, but it's actually just as responsive as Opus, just that this one happens to have a little bit more things in the header, and also the problem with the font. I think that it's just the same problem as the font, because if you see the original one, which is right here, it's also not very responsive. And also this is a problem to start with the original, because what's this search bar? It's useless. And the thing is that this font family actually takes less space than this font family. So that's why this looks like it overflows a little bit. But for the rest, it's actually quite good. I would say that both deserve the point, especially because Codex spent 5 minutes on this, whereas Opus spent 20 minutes on this. And I feel like I can fix this in just a couple of minutes in Codex, just prompting it to fix the font size, the font family, and maybe even fix the header search bar. So yeah, I would say that this is a tie as well. So that basically means that the final score ends up being 4 for Opus 4.5 and 2 for Codex. Okay, so we have effectively tested Codex against Opus over a bunch of different tasks, and I can see that they are actually very different models, but they are both incredibly powerful. It is never completely fair and completely straightforward to make a score-based comparison of these two models, because they are very different, and they are also both super powerful. But I think that some things are quite clear from this. I think that it is clear that Opus 4.5 is pretty good at UI and front-end design. However, I do feel that most of the time, especially when using the front-end design skill, its UIs have a tendency to look very similar with that italic text and all that. On the Codex side, I actually enjoyed coding in Codex a little bit more, because it just felt a little bit more swift. It is faster, and I do value a lot the fact that it is capable of completing very complex stuff like this code migration in a very short amount of time. So it did it in, as you saw, 5 minutes. However, Opus was able to do it too. Ultimately, it comes to your specific workflow and which one you prefer, and trying out both tools and seeing which one is the best for you. So there you go. I am a big fan of both of them, and I actually use both of them every single day. So thank you very much for watching. It is a great pleasure to be here with you, and I will see you next time.